Once your design is complete, you'll be able to print out your design. It'll take 2 pages because on one page you're going to print out the bottom layers only. Make sure that they are marked as black and solid and not mirrored. Since they're the bottom layers, they're mirrored already. In a separate print, print out the top layers only. Make sure they're black. You don't have to make them solid, but do make sure this is mirrored, because since it's showing up on your top layer, it's not showing up as mirrored, but when you flip that over onto the circuit board, you're going to need that mirroring. By printing out your designs, we're able to tape them together with somebody else's design onto a sheet of paper. And that way, I'm able to get multiple designs onto one sheet and photocopy them onto the toner transfer paper. This comes out like this. I try using different photocopiers to do this and different settings. Right now, I'm using a transparency setting with a photo setting and setting the contrast all the way to black. People quite often ask me which paper I use, and this is the best paper that I've found for doing toner transfer. It's available from Giotto Paper in Coquitlam, and it is Paropy CL Metal Plus. I think it's about $50 for 100 sheets, so somewhere around 50 cents a sheet. That's why I try and like to get multiple designs onto one sheet if I can. It doesn't really matter if we can't, but it's worth a try. You know, here I've got 4 designs, so that's saving a buck or two here. That's important when you're teaching high school. Your budgets are pretty tight there. Cut out your designs for the bottom layers. You can cut out the top layers too, or you can leave that for later. As you're cutting, try not to get your greasy fingertips onto the part of the toner that you're going to be transferring. That toner needs to be able to stick to the copper, and if you've got a layer of oily fingerprints in between, that's not going to help any. Here's 2 different designs, bottom layers, nice and solid and ready to go. We'll cut out some copper plated board in just a moment. Meanwhile, when people cut this stuff out, they seem to think that I enjoy throwing their leftover paper into the recycling for them. Please make sure that that ends up in the recycling when you're done. I am watching. Over by the shears, we should have a couple of sheets of single layer copper clad board that you can cut your parts out from. Try to use up the small bits of scrap first if there's something the right side. This is not copper clad board. This is actually a piece of copper. I don't quite know why it's there, but you're not going to be able to etch the copper off of that. So find something that matches up nicely. If you have to err on slightly oversized, well, it's okay to be slightly oversized. This one was oversized to begin with. This one right here, because I'm making 2 different designs at the moment, looks like I'm going to have to trim that down. I'll mark that with a pencil or a scratch, and then I'll cut that off in the shears so I get boards just about the right size. Again, if it's a little oversized, that's okay, but don't go too crazy. Bring your freshly cut sheets over to the etching corner of the room where we've got some steel wool. Use the steel wool to put a nice polish onto the board. Kind of hard to do with just one hand. Here you can see I'm part way through polishing the board. You can see the difference in shininess that a bit of polishing makes. That removes the oxidation layer. It's going to make your soldering go easier in a little bit, and I think a little bit of the surface roughness from the scratching with the steel wool actually helps with the toner adhesion. Once you've done polishing the board, give it a quick rinse with some Windex to make sure that you've got your fingerprints off of here. Dry it off with some paper towel, and just to make sure it's 100% dry, I'll just sometimes set it on the corner of the hot t-shirt press, and that will just help evaporate the water a little quicker. Make sure that you've got the bottom layer in your hand, okay, and that's got all your prints on it, that you're not touching anything with your greasy old fingertips, that your copper plate is nice and clean. Looks like there's a few little specks of dust on there. Just blow them out of the way, and then carefully place your sheet right down on there. You can give it a small press right in the middle to make sure that it stays put, and then close the lid on the t-shirt press. Hit the button right here. Right now I've got the temperature set for 330 degrees, it's all warmed up. And I'm giving it about 70 seconds to do the toner transfer. I've played with times and temperatures over the years. 310 at 60 seems to work really nicely. The manufacturer suggests 330 for 90, but that's for a decorative application. Again, it's something that you can experiment with a bit, but this seems to work. When your time is up, open the t-shirt press and then carefully flick your piece off there. I suppose a clever person would have come prepared with a stick, but use those tough shop teacher fingers. And then we put a weight on it to cool it down. You want to make sure it's 100% cool before removing the toner transfer paper. Adding a little bit of pressure while it cools, I think, helps to ensure that the toner sticks nicely. It should cool down fairly quickly. Once it's cooled down, you're ready to remove the toner paper. Sometimes you have to kind of work to get into a corner right there, but this is an exciting part because you find out whether or not it's actually working for you. Again, a little easier to do with two hands, but this is looking promising so far. When it comes off, the toner should all be on the board and none left behind on the paper. That's a nice toner transfer. Now it's time to inspect the toner transfer itself. Even a good toner transfer can have small cracks. You can see right along here, there's little bits of copper bubbling up and showing through right there. I don't wonder if that means that we had the temperature just a little high or left it on a little too long. It has adhered nicely, but in some places I can see copper showing through right in there. I'm going to go over some of that with a fine-tipped Sharpie just to fill it in. Anywhere where you can see the copper shining through is a place where the etchant's going to be able to make it through as well. And when the etchant makes it through, it can create some problems. Here's a board that I did earlier where I didn't get quite enough toner sealing things off. You can see that down here, this trace right here really didn't have enough protection. I probably also left it in the etchant tank a little bit too long. Need GoPro-like image stabilization. You can also see in here that some of my pads didn't etch up particularly well. I'm not so fond of how that all turned out. In fact, I don't think that board is going to be worthy of manufacturing. This one over here turned out pretty well, but it also has a few little glitches on it that I only found by doing careful inspection with a multimeter set to continuity mode. In continuity mode, when you touch the two leads together, stay put, my friend. Helps if I turn it on. In continuity mode, when you touch two leads together, there we go, it goes beep. And that beep can help you to determine whether or not you've got a continuous circuit on your board. Using continuity mode helped me to discover a tiny little error that you almost need a magnifying glass to see. Where is that little error? Right next to that speck. Might be more visible over this way. Can you see that pencil dot on there? If the light catches it just right, there is a tiny gap. I couldn't see that with my naked eye. I also didn't see a tiny little gap next to that mark right there. That one might show up under. Even under magnification, it's not showing up in this light. It shows up to the eye under magnification. You can see right here that these traces turned out much nicer than the ones on the other board. This board has a couple tiny little things to fix, but we can probably fix those two little gaps just by putting a little bit of solder over top of them when we're soldering. Everything else should be fine. That was board number 2. I was using the big photocopier with its darkest print setting and the transparency setting. Here I've got the smaller photocopier, and we're going to try etching this one up as soon as I go over some of those tiny little traces that might just need a little bit of Sharpie to help them out on there. Remember, if you can see copper, so can the etchant, and it's going to be etched. Attention to detail at this stage pays off and a lot of time saving later on. You can probably see now why I like to use about a 20,000th of an inch line spacing and 20,000th of an inch or 20 mil line weight when making the boards. And that's because that is about the thickness of a Sharpie, and that's about the ability of my hand to draw things in neatly. In fact, right down here I probably went a little bit overboard, and while I don't have a Sharpie eraser, I do have an X-Acto knife available, and that X-Acto knife can scratch out anywhere where I might have been a little over-enthusiastic with the Sharpie. So I've been spending a few minutes here just shining this back and forth and looking through here, looking for any exposed copper that I could find. I think I've got it just about good. And having the light and the magnification really helps, but if that's not enough magnification for you, we do have a little bit more available in the shop. We've got a couple of digital microscopes around. You can adjust the focus right here and the zoom factor right back here. As you raise and lower it, it zooms in closer, and then you just adjust your focus to get a nice, sharp, crisp image. The lights can help illuminate what's going on down there as well. Just looking around at that toner on there, you can see there's tiny little gaps in it that will be etched through, but they're not continuous and they don't break all the way through any of those copper lines. Most of the copper lines, the toner lines, are pretty good. While we're looking at them, let me mention that this is not ink that we're looking at, it's toner. And toner is a powdered plastic that is electrostatically attracted to the paper in the photocopier or in the laser printer, and then it is thermally pressed into the paper. And that's why we're able to do a heat transfer of it later on onto the metal. So just starting from an inkjet isn't going to give you the results that you want using this process. You'll have to use an inkjet and run it through a photocopier if you're starting from an inkjet. Looking over this right here, it looks like we've got continuous lines along most of our toner in there. It's not 100% perfect, but compared to most toner transfer processes, that's pretty good. You can even see the individual little pixels from the photocopier that resulted there. You can also use this for taking a look at your finished boards. And here's a finished board that I said we had a tiny little gap in the line, and we couldn't show that easily using hand magnification. But that's the tiny little gap that etched through right there. So either I left it on the etching tank a little bit too long. There you can see that was where I had some little gaps in the toner. That's okay, that's all going to be covered up with solder. But you can see that we did suffer some damage down there, and that's not going to solder up quite as nicely as a perfect joint. I may have etched this end of the board just a little bit too aggressively. Oh, and I think I just found another gap right on there. I'll have to go get my pen and mark that. Whenever I find a tiny little gap that's easily fixable, I'll just mark it with my pen so that I can fix that up before we come along too far. Okay. Generally what I'll do is I'll test them with a multimeter and in continuity mode. Surprising that I didn't find that one. There may be just a tiny little hair of copper right in there that's keeping that attached and giving us the continuity. But I'll put a dot next to it. I'll just lay a little solder over there when I'm soldering up the board. For longer errors, they're fixable too, but instead of just splicing solder over top of them, I'll trim off the end of a resistor and sort of bend it to shape and solder that down over top and use it like a splint. This is our old etchant tank. It's been a workhorse here, been here for years and years and years. It uses ferric chloride, which is an acidic etchant, so we have gloves available if you choose to use them. My experience with using ferric chloride over the years is that it will stain my fingers unless I wash them off right away, and it'll give me a little bit of dry skin, but I don't react to it very much. Certainly, we've got full protective equipment here if you prefer to use. Watch for your clothes, however, it does stain, and make sure that you have something over your eyes, because a little drop of ferric chloride in your eyes can be quite painful, and that's also why we have an an eye wash station right here. When something gets in your eyes, go ahead and just hit that button right there, crank that open full, and throw your face into the eye wash station and leave it there, and that will rinse anything out of your eyes. It's cold, but it's sure better than having any kind of eye damage resulting from the etchant. It's right there, and if you wear eye protection, you'll never have to use it. I've only ever had one student in the last 12 years have to use that, and guess what? He wasn't wearing his eye protection. Okay, so this is our etchant tank, and you can hear it bubbling away right in there. If you'd like to insert your board in here, just know that this dial right here turns the pumps on, and this one turns the heater and the entire thing on. To stop the pump, the easiest way to do it is just to turn the whole thing off, and then to carefully lift the lid. Now I've set the lid up to open this way, so that when you take your board out, it goes directly into the sink with the minimum amount of fuss and muss. I used to have it opening the other way, and as you can see, we got ferric chloride everywhere. So here I have one board in there all ready to go, and I've got one board that's been etching for a little while, and you can see that this tank doesn't necessarily have the most even distribution of etchant in there. So every now and then I'll come along and I'll rotate this to try and make sure that I get even distribution of etchant onto my board. Remember to close the lid before restarting the tank, and remember to wash your hands off. In fact, I like to leave a little bit of water, not quite that much, but about that much, running the whole time I'm here, so that anytime somebody gets a little bit of etchant on them, they can rinse it off right away. In the event that you have a small drip of etchant anywhere on the sink, I've got paper towel right here. Just grab some paper towel and wipe up your drop with a wet paper towel so that there's no stain left behind. Remember that your paper towel goes in the garbage, not left sitting out on a bench. You'd think that I wouldn't have to mention that about, cleaning up after you do your paper cutting and making sure that the paper towel ends up in the garbage. But yeah, apparently I do. Anyway, the water's running there nicely. The boards are etching. And every minute or so, I'll just come along here, turn the etchant tank off, lift the lid part way, just so I can go in and take a look at what I'm doing. If you turn the tank back on and the pump's not running, remember the pump is on a timer. Just go ahead and run it down there. As I go along, I've been looking in from the top, watching the process, and I've been able to watch my boards etching. Again, I don't want to go more than a minute or so without checking how it's going, because I could over-etch the board. When the board looks done, I lift the top and take it out there. Notice how any of my drips of etchant dissolve in the water right there. And I can rinse off that fine little bit of etchant that's left behind right there. So I'll be able to take a closer look at that later on. So far that's looking pretty promising. Those look like nice continuous layers along there. And you'll notice that one tiny little drop of etchant ended up on the edge of the sink. If that dries there, that's going to stain. So I just wet a cloth, come along, wipe it up, and now, while it's wet, that's nice and easy to clean up. Here's a board that's partly etched. So you can see that I want to avoid blasting any more etchant, or not as much etchant, onto the parts that are already etched, and rotate the board so that I can go after the remaining copper on there. In the event that you have to leave or do something in between, you can rinse the board off and leave it just like this, okay? and no problem, you can come back and put it in the etching tank later, but this one's going back in right now. I made sure the board that I'd already etched was nice and dry, and so I'm just going to bring that over here. And of course this is easier to do with two hands, but I get some paper towel and I give about 3 or 4 pumps of acetone onto there, and you can see that the acetone gets that nice and wet, and the acetone now goes in and smears off any remaining toner. This is a lot easier to do with two hands, so I'm just going to put this aside for a moment and do it with two hands. And here's my board ready for testing before I take it and drill it. Now you can see that some of the toner got smudged back and forth because I was trying to wash it off with one hand. And really the acetone comes off cleanest if you get in there with and hold the board with two hands. Make sure you get a good coat. And I think what happened there was that the toner was so thick and heavy that it built up on the paper, and I was smearing it back and forth while I was trying to wriggle it around with one hand. You can kind of avoid that doing that with two hands. I also find that sometimes using one of the washable cloths, rewashable cloths from the auto shop will do a nicer job than just using the paper towel. So this board is now ready for testing, but you can see down we made it around that corner pretty nicely, and it doesn't look like we've got any jumps between those boards. And just looking at the toner or looking at the copper, it's a lot shinier and more complete than we've had on some of those other boards that I was showing you where we had problems. So I'll take the multimeter now, and I'll go from one end of a line. So I'll start right in here, and I'll test, and I'll follow that line along electrically all the way down to there, and I'll follow this line all the way down. Where does that one go? It comes around here, comes around over there to make sure that goes okay. This is a big long run right here. I'll come and I'll test, and I'll use the multimeter, and I'll follow that line right along there, and it should beep all the way along right there until it comes up and over here and around like that. And this one's pretty critical too. In fact, all our lines have to beep. The other thing that you can test for is when things get really crammed together down here, put your multimeter probe on this side and then put it on that side, and it should not beep because those are different signals. You can see right in here, it's pretty close there. That was a little bit of enthusiastic sharpieing I did right there. And that might be a tiny little gap that it's hard to tell with the eyeball, but the multimeter will always tell you the truth. So test that with the meter before you go on and start drilling your holes or putting any components in. It's a lot easier to identify any problems and fix them at this stage than it is once you've got the components on there. Again, electronics is about attention to detail and not rushing, and that's a skill that I think if you can help students develop that they can apply to other things in their life. Here's a board where I actually washed it off with the toner off with two hands, and you can see that the toner came off a lot nicer and a lot cleaner, and I didn't get as much smudging left behind. A little bit of smudging's not a problem. Even that much smudging's not really a problem, so long as the toner's not on your copper traces, because you're going to want to solder to them. I have seen people try to solder to the toner. It doesn't work that well. There we go. Next step, we'll be drilling things out. Okay, I lied. I did do one more step, and I went and put a coat of spray paint on the top side. I only did that right now. Normally I like to do it after I'm done all my drilling and everything, but I always wait until after I've done the acetone. The reason I put that on the top side is so that later on, when I transfer the top layer diagram onto it, I'm transferring the top layer diagram onto a nice colored layer of paint. Just looks nicer that way. Again, if you can wait until after you've done your drilling, then you're less likely to scratch up that top layer, but I've got to leave the shop right now, and this will let it dry overnight. Once you've tested your board and you know your traces are good, or at the very least you've marked off the one or two that aren't so that you know to fix them later when you're doing your soldering, it's time to trim up the board. You've got the board edge dimensions around there, and it's time to drill out the big holes. I like to drill out the big holes first. If they're in a corner like this and separate away from anything else, you might want to use a hole punch. I've got hole punches in different sizes right down here, little mini Whitney punches. And this little one down here at the end with 5/32 does a great job for a lot of little holes and mounting points on your boards. Check the diameter of the drill bits that you're going to use. For your integrated circuits, you probably want a 0.9 mm drill bit where those sockets go in. For everything else out here, probably like a 0.7 will do the trick. It kind of helps if you get your components first, and then you can take a look and see what diameter the components are going to need, and then you can do a test fit, and you can always go to a bigger drill or put a bigger bit into the one that you're going to use. Once you've finished drilling your 0.9 mm holes, or once you've finished your 0.7 mm holes, it's probably a good idea to switch to another drill press that's got the right size drill in it. And that just saves you the time of switching out drill bits. It's not hard to do. Just remember, if you need to lock the shaft, you can push that little button right down in there, and then you should be able to change the drill bit. Occasionally drill bits will get dull, and you'll notice it. Sometimes the end will start to look pointy, which makes it look really sharp, but really that's just because the hard fiberglass material in here has worn away the edges of the drill. And you know what? If it's working, that's fine. Keep using it. You'll know that something's wrong if it's not going through smoothly, if you can't get it to go through the center of the hole, or if when you look at it kind of on an edge, you see the copper starting to pull up a little bit. If you see anything like that happening and you're not getting nice, clean, crisp drill holes, let me take a look at that, and maybe I can get you a new drill bit. When you're all done your drilling, please remember that you've just created a whole bunch of dust. We've got a little vacuum over here, and you can leave the workspace clean for the next person. You can even wipe it down with a damp cloth. Thanks. When you think you've got the board drilled and all its holes drilled, hold it up to the light. That can really make the holes stand out and let you catch the ones that you've drilled and the ones that you haven't. Although you can come back and drill another hole in later on, it's a little bit of a pain. So care and attention at this stage of the process is a good thing to do. Make sure you've got all those holes, and again, 0.9 mm works great for the integrated socket pins, and for the two pins right down here for your touch pads, and 0.7 works for everything else. The benefit of using the smaller drill, the 0.7, is that you leave more of your annular ring behind, so you've got more copper to solder to, and you've got less gap to fill between your component lead and the pad. So use the smallest drill that's going to work, so long as you can do it efficiently. I think I've got everything on that board. Here you can see two drill bits. The top one is a worn one, and you can see right there, even just with the naked eye, that the tip is starting to point in a little bit. If you look at it under higher magnification, you can definitely see the change in that top one versus the nice crisp edges on the bottom one. And the top one still drills, but it's not its full 0.7 mm diameter when you roll it back and forth like that. Materials come off, so if you're just drilling in with the tip on that top one, you're probably not going to be getting the 0.7 mm hole that you want. So anyway, when your drill bits start to look like that, it's time to get new drill bits. Now it's time to add the top documentation layer, and that's why we printed that out. And you can use the holes that you've already got drilled in the board to get it aligned. Now you can go with a board just using its plain FR4 fiberglass kind of color if you happen to like that yellow, or you can take your board, and I'll usually wait until I've got all the work done on the top layer before I go and spray paint it. But you can spray paint it and then put your toner transfer onto the spray paint. It just gives it a little nicer look. If you're going to do that, make sure that you allow the full 24 hours for the spray paint to dry before you go and do the toner transfer, because otherwise you can get weird things happening when you apply wet paint into the machine, and you may be spending some time cleaning it up afterwards. You can align this just by eye, and again, because this one's not being used as a mask for etching, it doesn't have to be perfect. However, if you get it aligned nicely, and you can use your holes as a guideline right there, leave yourself a little bit of an overlap on the paper, and then you can use a little bit of tape to hold that in place. Remember that you're going to be putting this down so that it goes together like that, with the documentation coming out on the top layer. Adding the top layer can give your board a pro look. You can see the jumpers in there ready to be aligned. It also has indications on which way the integrated circuit should go in, helps you figure out which component is which, and if you want, it can also be used as a little bit of signage or decoration on your boards. So if that's going to be the surface of the board, then you can put your name on it, whatever you want, customize your designs. So there you go. Now you're ready to start soldering. So when it comes time for soldering, the first thing you're going to want to do is fix any of the traces that didn't come through nicely. Here you can see that I've used clipped off leads from a resistor, or you could use a fine gauge wire, and I've bent them to follow the shape over top of the gaps that I identified and marked in felt pen. So this area of the board right here got over-etched a little bit. Because there was only about 3 gaps in here that needed to be fixed, and they seemed like fairly easy gaps to fix, I thought, okay, this board I'll keep. There's a couple other that I've gotten rid of. Actually, while I'm looking at it carefully, that might be a gap up there too. I better get the multimeter out and check that. Remember that if you put the multimeter into continuity mode, some of them will beep at you. Other ones will just show on the display whether you've got a connected circuit. Anyway, when you're soldering this in place, get it bent roughly to shape, and then what I'll do is I'll make sure it's long enough to connect to a good section at this end and a good section at this end. I'll start by tacking it to a good section down here, wait for it to cool a bit, and then I'll tack it to a good section down here. And sometimes then I'll just follow along with a little bit of solder along the entire surface. It's a bit of a fine hand skill operation, but with a bit of practice, you can save some of these boards that have been over-etched in 1 or 2 locations. So take a careful look at your board. Once you start adding components, it's going to be a little more difficult to identify gaps in your traces and track them down and troubleshoot them. Once you've got the board good, and hopefully you don't have to do any of that. Hopefully you get a beautiful etch and it all comes together, something like this one right here, where we didn't identify any errors with the multimeter. Or this one right here, this one came together without needing any repairs. So hopefully you don't have any repairs, but if you do, they're not that hard to do. Once you get it repaired, the first thing to do is to start soldering, and again, put your lowest components in first. So I start with the jumpers. That way, when I put the jumpers in, I can put the board down like that, solder them in place, and they're held in place by the board resting on top of them. The next lowest component will be the resistors. So I'll do the resistors next. Resist the urge to insert all your components and try to solder them all at once. Here I've got the resistors inserted, and I've soldered 1 or 2 and trimmed them off and stopped to check to make sure I'm getting good solder joints. A good solder joint should look something like a volcano. This one at the back right here, kind of in the middle of the screen, is looking really nice. That one in there is not too bad. The one in the middle of the screen right now is balled up just a little bit, but it seems to have a good connection with the copper underneath, so I've gone through and trimmed it off. I'll trim off a couple more in here, and then I'll solder up the remaining joints. Once you have the jumpers and resistors in, the next lowest item is probably the IC sockets. Remember to pay attention on the socket to make sure that you spot the little indentation. That's not showing up very well in the shade right there. Let's rotate that around. Right at the top right there, you can see there's that little notch missing right there. And this one, I've got it inserted down at that end. And that's really important because that's going to remind you which way to put the integrated circuit in later on. Now, because we've done a toner transfer under the top layer, you can see that IC2 has a little dot in one corner to indicate where pin 1 is. Pin 1 will always be immediately to the left of the notch. So make sure that this is lined up as pin 1. For IC1, however, you can see that on there, when we put it in, it actually has the notch indicated on there. So make sure the notches match up. Let me rotate that around so you can see a little bit better. There's that notch on there. So make sure they line up. The electrons really don't care, but if that can save you from putting a chip in backwards and damaging the board later on, that saves you a lot of effort. There are different types of IC socket. You can see here we've got one with machined round pins. Okay. And we've got a couple down here with just pressed or stamped pins that go through. I actually find these ones work about as well as anything. They're slightly less expensive, and I find my chips insert into there a little more nicely than they insert into the round pins right there. But either one works very well. Just make sure you put them in the right way around. Normally a radial electrolytic capacitor will stick up quite high, but so I do them last. But if you design your board right, you can actually leave space for them to lie flat simply by bending them over. I'm going to do the same things with my LEDs on this board, so I'm going to do those next and leave a few of the taller components right until the end. Here you can see my electrolytic capacitors standing up because I got a little out of sequence and I put a, what was that, a 381 or something like that. Anyway, I put a different capacitor in right there, the red one, and it's standing up a little too high. So now my blue one's not going down far enough. To get it to go down properly, the trick is to insert it and to only solder one side. You see I've soldered that side right there. Now I can use my finger to push from the back, and I use the soldering iron tip just to melt that solder, and when the solder melts, I just push that down flush onto the board. That'll hold it in place, and then I can finish soldering it. That's also a useful trick when you're putting in your integrated circuits. You can always tack it at one end with just one solder joint on there, turn it around to make sure that it's sitting flush. And if it's not, then you've only got one solder joint to fix, and you can usually do that while holding it like this, using this finger to push on the back, and your soldering iron to heat up that one solder joint. Then you can tack it down at the other end, and then everything else should stay in place while you finish up your soldering. In some places, like right down here when I was soldering the integrated circuit, you can see that the solder jumped from pad to pad. Generally, that's not a good thing. However, it's okay if the design already had a copper trace going from pin to pin, as we've got right there. So those are the two pins that are joined together right on that one. In fact, all three of those pins could be joined together. All four of them, in fact. The ones that are closely together right in there. You can see that there's a copper trace going between those four pads. So if the solder joined those four pads together, they're already electrically connected, and they are supposed to be. Remember that when you're putting the board together, the component for the electrolytic capacitor had its pads pretty closely together. If you think there's any doubt that those two jumped together and connected each other, then use your multimeter to take a check and just do a continuity test. Those two leads should not be electrically connected to each other. Well, here's one where what I detected earlier during my multimeter test as just a tiny little error while I was soldering it up suddenly became a bigger one. You can see that big brown spot right in there as I'm struggling to get this nicely into the light so you can see it clearly. there's a big brown spot right on there, and that's where some trace pulled up. Now, I noticed that as I was soldering, so rather than going on and soldering anything else, I'm going to take a moment right now and fix that with a little jumper. Okay, that took a little bit more effort to fix than I thought, because when I went and fixed that one joint, another one decided that it was going to let loose. So that trace right there was just on the edge of over-etching, and when I hit it with a bit of heat, the copper just peeled right off the board. So anyway, in there right now, we have a piece of trimmed off lead, bent to follow the shape of the trace, and it is soldered to the leads that come through right there. So I don't know, is it easier to see without the magnifier on there? Actually, that seems to work out a little bit better under less intense light. There you go, that's maybe a good view of how it all came together. So as I was doing my fixing of the first trace, I did a test with the multimeter and discovered that in the process of fixing the first trace, I damaged another trace on there. So this ended up looking rather sloppy under high magnification, but going back and testing each of the connections with the multimeter in continuity mode has allowed me to confirm that my connections are in fact good. And while I'd never consider this a prime example of the best quality board that I've ever kicked out, the fact that my connections actually work, and it looks like I've got a connection right in the middle right there that shouldn't be there, but the multimeter tells me that that's not right there. I'm willing to go with what the multimeter says. So in general, if you've got a problem, we can usually fix it with the multimeter, and it might come out looking a little bit ugly, but the electrons really don't care so long as they have a path that forces them to go where they need to go. You're going to spend a lot of time fixing circuit boards as a high school teacher, so don't feel it's a waste of time if you end up fixing your own and it comes out looking something like this. If the fix works, that's going to perhaps save a student's project someday, and next time out they'll be a little more careful about not over-etching any particular part of their board. Just looking at the traces right there, if you look at that track right along the bottom, I probably should have been rotating that board a little more frequently while it was in the etching tank. You can see that the ones towards the top right there are nice and solid lines, but as we get down towards the bottom, there's a bit of porosity there, and that was probably an error that came from the etching process. When I was soldering the LEDs as my next step, I did the trick where I'd solder just one lead, and then I could go around, and if the LEDs weren't sitting flush, I could just push them back down and remelt that one lead, then come back and solder them up a little nicer. While I was doing that, I noticed that on this one right here, that the trace had been a little bit damaged. You can see on here, this is the board that I'd slightly over-etched and had to use little jumpers to fix some of the boards in that region. And it looks like I'd over-etched one of the LEDs leads as well, and hadn't noticed that prior. And so you can see right down in there, that's looking just a little bit ugly. I had a problem with it jumping over onto that trace right there, and you can see right down by my fingernail there. And yes, my wife tells me I need a manicure. You can see that the trace doesn't quite connect to that LED lead. We're going to fix that now. Because I noticed that before I trimmed the leads off, the fix was fairly easy. I just bent the lead over to cover the missing section in the trace, and now I'm going to be able to solder that lead right down into the trace. That's all the ground line, so it should be common for all the LEDs, but if I hadn't caught that, then that blue LED wasn't going to work. And there we have it, a little bend to the LED, and it's soldered right down onto the trace, and it jumps over the section that was over-etched. Again, this is the least nice of the boards, and I've got quite a bit of little fixes to do on there, but with careful application of some solder and trimmed off leads and bent over leads, you can fix a lot of your etching problems.
So I know we've mostly been showing errors and how to fix them, but these boards do work. And here you can see we've got a case around one of the round boards and it's working great and it's failing. Oh. The square birds work really well too, so I'm going to leave it to you guys to put yours together, and then maybe I'll make a video about how to make a case for these. This one definitely needs a case, something to hold the battery secure and keep your fingers from getting scratched up on the back. Have a good one.